Problem number 23. So now we want to, one last optimization problem. I want to be clear that you could get different optimization problems on the exam than these. These are just some examples to kind of help you work through, give you some idea of what the exam problems might look like. So we want to find the point on y equals 3x squared, or 3x plus 2, that's closest to the origin. So what do? We have our distance function. But first, so this is optimization. We have constraint and objective, which I actually didn't write out last time. I just realized, but that's all right. So our constraint is that y is equal to 3x plus 2, hidden in plain sight. Our objective is my distance function, d equals square root. And now let's think. So we have y minus 0 squared plus x minus 0 squared, because that's the distance between any point xy and 0, 0. So what do I get? I get d is equal to the square root of y squared plus x squared equals the square root of 3x plus 2 squared plus x squared. And when I did this in class, I did chain rule, but let's shake it up this time and factor out the function. I get 9x squared plus 12x plus 4. And that's just from FOILing out the 3x plus 2 squared plus another x squared. So I get the square root of 10x squared plus 12x plus 4. So now I'm coming around to the idea that doing it this way is easier. D prime is equal to 1 over 2 root this stuff. This is by chain rule. 10x squared plus 12x plus 4. And then times the derivative of the top is going to be 20x plus 12. So now I say 20x plus 12 is equal to 0. And I note I don't have to worry about the denominator because square root of all that stuff is always going to be positive. Or at the very least it might be 0 somewhere. But that won't be an issue. So I have 20x plus 12 equals 0. 20x is equal to minus 12. X is equal to minus 12 over 20. Or x is equal to minus 3/5. Y is 3x plus 2 equals minus 9/5 plus 2 is 10/5 equals 1/5. So it looks like my point that gets closest is minus 3/5, 1/5. Now by the first derivative test, which I also failed to do. By first derivative test, if I plug in something bigger than minus 12, I have a minus 12 over 20. If I plug in something bigger, I get a negative. If I plug in something smaller, I get a positive. That's because I have 20x plus 12. So this thing is increasing like this. Minus 3/5, 1/5 is a local max. Local max. All right.